I met Bob Ballard 8 years ago when we were starting solar issues with the solar company that I was a partner with to make a energy independent campus for this new thing called the Wakulla Environmental Institute that Bob led. He has been incredibly dynamic with his vision to regenerate a community that's sustainable. And Bob led us with the first classes of oyster aquaculture that I was a part of. And he's now still doing that, but we're moving on to Oyster 2.2, which is putting oysters back in the water to help clean water. So, Bob, would you come on up? It's my privilege to introduce a dear friend and a man of high courage, Bob Ballard.
Good afternoon. And I'm told I have like really short time so I need to move it along. But I was out with my students out in the water, Oyster Bay, and every year that we're going out for the first 2 years, the water was really green, loaded with algae, and because there's nothing out there eating it. The algae, the oysters were all gone. There wasn't. It was barren. And after 2 years, our students, we had put millions of oysters in the water. And what I was told was going to happen is what I witnessed happen, that the water started getting cleaner and clearer. And I witnessed it with my own eyes. And what loves clean, clear water? Seagrasses. It allows photosynthesis to come down to the bottom and seagrasses to grow. And what loves seagrasses? Everything, right? All the fish love seagrasses. So I went to President Murdoch of Tallahassee Community College, because Wakulla Environmental Institute is a part of TCC. And I said, we need to figure out a way to export this clean, clear water to the rest of Florida. And by the way, this was 4 years ago. Now, what we saw, the water getting clean and clear for about a month out of the year. The water's getting clear and clean for about 5 months out of the year. That's because more and more oysters are going into the water and cleaning up more and more. So President Murdoch came back and said, yeah, go ahead and work on that. See if we can't figure out a way to export clean, clear water. And I'm not high tech at all. I like to bring a show and tell. And so we developed a dome. Actually, the dome is 400 pounds, but I couldn't lift 400 pounds worth of concrete. And we came up with this dome, and the inside is a little tube in it. And for those of you that are worried about plastic, we have a non-plastic version. And we put oysters in here, 3-inch oysters, 5 of them. And what happens, because we're looking for restoring the oyster population in Florida, because 85% of the world has lost their oyster beds. In Florida, it's 90%. Put 5 mature oysters in here. What happens when they spawn, the egg and sperm get kind of trapped in here, and they fertilize. And they fertilize at a rate 50 times faster than what happens in nature. Only about 1% of the fertilization rate happens in nature. Inside this dome, it's about 50%, or 50 times that rate. So what happens, set this down, so I won't scratch anything. We go from this, day 1. This was day 170. And we pulled this out of the water 170, and I thought this was a failure because we didn't have any oysters on the outside. We just had barnacles. Then I looked a little bit closer. We looked underneath it. And we saw oysters. And we saw lots of oysters. It was teeming with oysters. And all of a sudden, we started figuring out that we did have a way to restore oysters in an area that once had oysters, but no longer because there's no seed source. We go to day 240, and all of a sudden now we're starting to see oysters on the outside of these domes. It's like, okay, we've got something here. Now you go all the way to day 450, and now it's teeming with oysters not only on the inside but at the outside. And we presented this to scientists in the Gulf of Mexico, and their jaws dropped because they were always looking at poaching in order to restore oyster habitat, which really never worked. And then when they saw this, they were like, aha, you figured it out. So what this does, this will send trillions of larvae into the system, overwhelming the system to help bring back the oyster population. And then when we went a little bit further, what do oysters eat? Algae. What is algae? What's harmful algal blooms or red tide made up of? Algae. Just heard back from yesterday from Moe Marine, and they confirmed the fact that our oysters are eating red tide and doing away with it. So we're doing product development, because we're not supposed to do research at TCC. And, but we believe with a little bit more product development, we can figure out a way to beat red tide because of oysters. Oysters are really important. Thank you.